Okay. Right, ladies and gentlemen, hopefully you will continue to see me. The whole point of today's lecture is that I want to show you something physically. Let's try and do it this. Okay, you're just gonna have to. I'm gonna hold it like this. More things to improve. Online people, see them. Okay, right. So the whole idea today is we are going. It's lecture 9. Yes, please. Okay, so today we're going to improve on what we already know. So first off, first slide. Congratulations. Woo! What are we congratulating you for? Well, you can now solve all your problems. Okay. Really, it's only week 4, and you know how to solve everything. Really. You can solve everything we throw at you now for 1A. Who believes me? One person. There's one person there. That gentleman there. Okay. Anybody online? Anyone want to believe me saying, oh, no, they don't believe me. Okay. Okay, maybe there's luck, maybe. But remember what I said. There are different ways to do something. And obviously some ways are better than others, right? So what we've really done is we've shown you one way to do selection, one way to do repetition, and you know how to work with the for loops and you now know how to work with the variables. And so it's basically everything you need at a very rudimentary level for solving all problems. It doesn't mean you're solving them well, which is where the next part of the slide shows that, yeah, you can solve it badly. Okay, so obviously we're not here to show you how to problem solve badly, right? We want to show you how to solve well. So what is one of our bigger issues that hopefully you have all encountered? Somebody like, no, okay. What is one of the bigger problems that you think might be a problem for you going forward? Any ideas, online people? Physical people? Anyone want to put their hand up and say, I would like the following to happen? Okay. Karen Maraba is saying repetition. Well, we did while loops yesterday, so we are handling repetition. Repetition is possible, unless you mean you don't like the way repetition is happening right now and you want to improve on repetition. In which case, I don't know. I mean, the while loop is pretty good at what it's doing. Okay. All right. So someone here, Chi Mahloko, is saying storing a large number of data. Does that sound right? Yes, that sounds like something we would like to do. And that's exactly what we are going to cover today. Okay. And that is, no, not congratulations. It's more, let's consider the following. Okay. So on slide 6, for the people who are online, slide 6, there is a question about, let's revisit our adding numbers program. So the issue here is this. When we specify how many numbers we want to add together, do you remember this code? This gentleman looks very confused. Anyone online also confused? Oh, you see, someone's really spoiling it. It's like using arrays. Okay, yes, we are going to do arrays today. Spoiler! Dude, spoiler! Okay, so we're going to work with arrays today, all right? And we're going to introduce to you the concept of arrays, but we're not going to go full-blown into arrays. We're just going to dabble into arrays, and then we're going to start working with arrays as much as possible so that you get to a point where arrays become second nature to you, because you're going to find that arrays are really, really useful. But here is an example. Slide 6 basically gives you an example of why we work with arrays, why the arrays is a necessity. So let's say with our current code that you look at on slide 6, you'll see that I've got this arrow, this purple arrow pointing that says number is equal to cint input box, add number, and it specifies which number you have to add. Now, every time the user enters a new number, what happens is that value gets stored in the variable number, but the previous value of number gets thrown out, right? So in other words, we have no way of tracking exactly what values were used at each point. And that might not be a good thing, is it? Think of the many applications you have in your life. Imagine here at UJ, we are only able to store one mark of yours at a time. Can you imagine how disastrous that would be? Yeah, it would be. So imagine now I go, all right, congratulations, ladies and gentlemen. You did very well in Informatics 1A. So your final mark for Informatics 1A is 95%. Right? Sounds good? Okay. Yeah, that gentleman is like, whoa, yeah, you'll take that. You'll take the 95. Okay. And then Maths comes along and goes, oh, you got 60 for Maths. So what happens is, because UJ is only capable of storing one mark for you at a time, what do you think is going to happen? You're going to get 60 for everything. For Maths, computer science, business management, blah, 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 blah. Who's happy about that? Okay, the physical people are like all shaking their heads. Online people, what are your opinion about? What are your feelings about that? Yeah, I'm asking you. Share your feelings. Any feelings? Sad. They're sad. Okay. Are you sad too? Okay. So we don't want that. We want ability to store more than one value at a time. And obviously, with our current program, if we move on to slide 7, the reason why we said this is fine is because the question never asked us to store it. But, of course, there's a but here. Okay, next slide. Then they said, but if we go to slide 9, it's like, wouldn't it be cool if we could keep record of these numbers? And the answer is yes, it would be cool, but it's not just only cool, sometimes it's necessary, right? Okay, it's necessary. So, and then some of them are like, no, because what if I did better in the other ones and get the bad mark for everything? Yes. And then there's an individual who goes, I mean, for Maths, I'll take that 60. Okay, yeah, okay, I would also take that 60. Sometimes I'm terrible at Maths. So like, yeah, that would be a big improvement. I would take that 60. Some of these people here are like, absolutely not. That's insulting. Okay. But can we do it? And we all know we can, obviously. Otherwise, we wouldn't be having this conversation, right? So the next 2 slides, I'm actually going to ignore there, okay? I want to show you something else instead. So hopefully I will get this right. This is why we're having this. Okay, so let's think about variables, okay? We all know that, and then if you really are following on the slides, think of a variable that we're working with right now as a chair that's capable of seating how many people? One person at a time, all right? Because that's how variables work. They only store one value at a time. So assume that we go, no, we don't want to store one value at a time. We want to store more than one value at a time. So what can we do? Well, it's easy. In programming, we simply say, that variable that stores only one value at a time, let's expand it. Let's expand the variable so it is capable of storing more than one value at a time. It's that simple. That's the solution. So how do we tell VB that this variable is not only capable of storing one value at a time? So if you go to slide 13, you will see there's some lines of code here. Okay, if you take a look at those lines of code. I have 3 variable declarations in the gray block. Okay, effectively, the first line, you should all know and be familiar with it. That's how you declare variables normally. However, the second and third line is what I would like you all to pay attention to. Okay, so the second line, you'll notice, okay, and can I just get a show of indication from online people as well as physical people? What do you see is the big difference between lines 2 and 3 in comparison to line 1, which is how you've been declaring variables this whole time. Online people, share your thoughts. Okay, it has brackets. It has 10 in brackets. And then some people are using trainer. It's got parameters. Okay, someone like, it's parentheses. Yes, that's it, right? You see the brackets there. All right, so that's effectively it, ladies and gentlemen. If you want to tell Visual Basic that this variable must be expanded to take in more values, you do so by using brackets. You do so by providing the brackets after your variable name, not after the end of the data type, which VB will allow, but you don't want to do that. You need to provide variables after the variable name. Okay, keep that in mind. Visual Studio is not going to go, warning, 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 what are you doing when you put brackets at the end of the data type? So in other words, if you've got private one number as integer and then open bracket, close bracket at the end of the data type, Visual Studio is not going to complain. So online people, please be aware of that as well. Okay? That would be wrong. That's not how we do it. We do it this way, which is the brackets come after the variable name. What is the difference between the two? What we're doing now is an array. If you put the brackets at the end of the data type, it's what we call an array list, which is something different, which we don't want you to do. We want you to program from the ground up, so we want you to work with an array. Okay, normal array. Keep that in mind. Right, now, as you all note, the brackets, what do the brackets indicate? So on line 2, private many numbers 10 as integer. As you can see here, I've written down that when you declare your variables and you specify the number in the brackets, you are saying that this is an array. Okay, it's a variable capable of storing 10 numbers at a time. That's what it means, 10 values. And this is what we call a fixed size array, meaning that it can only store 10 values, not more, well, it can store less, obviously, but it cannot store more. And when you use a fixed size array, if at the beginning of the program, you already know what the size should be. So for our problem, our adding numbers together problem, and this is online people as well as physical people, can we use the second option for our problem? Yes or no? You understand the question? So you know what our adding numbers problem does. Okay? The second line is only for if we know exactly how many numbers it will be required to store. Right? Can we use the second line for our problem? No, we can't. Why not? Because we don't know how many numbers there are going to be. The user will tell us how many numbers there will be. And only once the user has typed in, I want to add in 7 numbers and press that button, will we know, oh, we need to create space for 7. So in other words, for our particular problem right now, we need to use the third declaration line, which is very much like how you answer tests, isn't it? If you come across a question you don't know the answer to, what do? You'll laugh. Online people, are you laughing too? What do you do when you come across a question in your semester test or in your test in matric last year and you don't know the answer? You skip it. See, the online people are being very honest. You're just going, ha ha. Right. You skip it. That's what you're doing here. When you look at line 3 on the variable declaration, you're saying, well, it's supposed to store multiple values. I don't know how many, so I'm not going to tell you. That's it. It's very obvious, isn't it? See why VB is easy. You know why it's called Visual Basic? It didn't say Visual Advanced. Visual Basic. Okay, so brackets mean, I don't know, I'll tell you later. Right? Because you skip it for now, but eventually you get back to it and you go, I know the answer, or I think I know the answer, I'm going to try it now. And that's exactly what's happening. So the third option is what we call a dynamic array. In other words, at compile time, so you know when you press the play button, at that point, you don't know how many values it's meant to store. And so it's dynamic. You'll tell him later. Once you got the value, you will tell VB, listen, prepare this much space for my variable. Let's go. Okay, and then there's another question. Emma Ngomba is asking, does VB support multi-dimensional arrays? Yes, it does. But baby steps, my young Padawan. Baby steps. Okay, so we are now getting to this part of the lecture, and that is on slide 14, you will see that I take the exact same code from the adding numbers program, and I basically added one line at the top just before the while loop, and then I modified the line of code where we describe how we input the values into our variable. So instead of entering the value into numbers, I now store the value into my variable, which happens to be an array now. Okay, so let's talk about the first line. It says read and then the name of my variable, which was called not sure, but many numbers. We knew it's going to have many numbers, we just don't know what the number is. Ladies and gentlemen, please don't name your variable not sure, but many numbers. It's just for this example, we're doing that. Okay. And can you look, unfortunately, I can't share the screen. That's why I need you to download the slides of Eve at the moment. Okay. Because once I do this, I'm going to do the demonstration. Okay. So, how do you then, after the fact that you left it out blank and said, I don't know what the variable size, the array size is. Now you go, oh, I know what the array size is. So I'm going to tell you what the size is. You have to tell them a specific instruction, and that is you go redim. Now redim means redimension. In other words, the size. You know, dimension refers to the size of anything, the size of a box or whatever. And then for the online people, you don't see, but the physical people will know that I came in with a box for my demonstration. So redimension, redim, and then you provide the name of the variable, and then in brackets you specify what the size of this array should be. Now by now we know what the size of the array should be, and that is numbers. Okay, so in other words, the user specified it will be so many values, and you now resize the array. Can you do this in the other button? Oh yes, you can. But for the purpose of this demonstration, I'm just throwing it all together in one section to show you. The important part, why do we use redim? We use redim because, remember, there are two ways to declare the size of an array. One is you know what the size of the array should be before the program is even run, which we do not know in this example because the user is going to specify how many numbers there will be, right? So we're going to go with the second option, which is to redim, use redim to say, well, previously I didn't know what the size should be, but I assume that by the time we get to this button, which we are pressing to add numbers to the array at a time, I do know what the size of the array now is because in the previous button, someone would have specified I want to add 20 numbers and press the button. And you would have stored 20 in numbers. Okay. Does this make sense? All right. Okay. Please note that the attendance code is pointless for you to enter at this point. You'll be considered late. All right. But let's concentrate on that next line where previously it was just number is equal to CN's input box. Now you'll notice that it's actually the name of the variable, but then afterwards in brackets, they have the variable counter. Why is that the case? Okay, and this is where I want to do the demonstration. Okay, so hopefully you can see there's my box here. Hopefully you see my box here. Right, okay, now let's assume that this box is my variable. This is my box with the variable. Okay, can you physical people see the box? Okay, right. Now, okay, let me take this stuff out the box first. It's like a magic trick. Oh no, people, don't tell them what you see. Okay. I'm trying to make a point here. Okay, so box, box, empty box. Empty box. Okay? You know a variable is a placeholder. So this is a placeholder. I'm going to put things in it. Previously, we could only put one thing in here at a time. But now we've expanded the space and said, this box is capable of storing whatever number of things we want. Okay? Before you start, you obviously have to specify how many space you can put in, items you can put in. So this array, I'm saying, can store 100 things. 100 things, okay? Right. Still following me, online people? Physical people? Following. Right. So I'm going to start putting 100 things in. What's wrong with the scenario? Well, first and foremost, ladies and gentlemen, I'm putting in a lot of junk in here. Besides that, it's different things. There were some papers. There's my cell phone. There's my office keys. All different data types. Rule number, you probably came up with a bunch of your own rules already. Rule somewhere in the picture. Arrays, when you create an array capable of storing multiple values, they all have to be the same data type. Okay? They can only be one type. You can't stick in a phone, some keys, which are different types, into there. Okay. But I want you to imagine that it's all the same. Okay? Let's assume this is all the same stuff. Okay? Okay, right. If it's all the same stuff, what's my next problem? And I know some people are saying, why is it counter and not numbers? And K. Malale is saying, for index of the data, I think. What do you think, physical people? Right. Think of this. Okay, so I did the box for a reason. So, you know, I stuffed a whole bunch of things in here. Okay, let me continue to stuff it in. Look at the mess. Look at the mess. Look at the mess of my box. You see that? Online people, you seeing the mess? You're going to watch this video again, aren't you? Right. Okay, it's a big mess. Big mess. Now, I go, I need that one piece of paper. Hang on. Somewhere, yeah. Is that work? Is that helpful? Oh, you want to see the mess? Okay, here's the mess. Oh, a mess. What's the problem here? Can you imagine this? You go to the bank and you go, hi, I'd like to, I know, you're like, what's this going to the bank nonsense? Online banking, man. Okay, but let's say you go to the bank. So I'm going to go to the bank now. I'm going to the teller here, this gentleman here. You don't mind being on camera, right? Okay. And I go, hi, sir. I have an account with you guys. I'd like to withdraw money from my account. And you go, sure, give me a minute. And then you go to the back room. And you go, give me 5 hours. I'm looking for your bank account details. Would that work? No. Would it work? No. So what do we need? We need instant access to where everything is. And that's where the variable, when you look at the code, I don't know. I don't even know if you see it. If you see that counter variable in brackets, that's where this comes in. Your array gets expanded, yes, and you can store multiple values. But you can't just chuck it all in and then say, no, you can't do that. You've got to know where everything is stored. That guy there is just laughing because he knows exactly what I'm talking about. So what are we going to do? We are going to store it in numbered locations. Does this make sense? And that's where that talk about an index comes in. Effectively, we say this array, so remember user goes, I want to add 20 numbers. So you go, fine, I'm going to expand the space to 20. Okay? But I'm also going to number these spaces in this big array to 20 spaces, which we call elements. 20 elements. And each element has its own address, starting at 0. Okay, now we don't use 0, so when we resize our array and we go read them, not sure, but many numbers, and that numbers is 20, what really happens is it creates an array of 21 spaces. And please work like that. Please don't go, oh, I'm going to go -1. Keep it at numbers. All right? And ignore the 0. We don't use 0. There's a reason why we don't use a 0. It makes it easier for us. I promise you this. And then, where would you store the first number for adding up your numbers? Logically. Who wants to answer that question? Just logically speaking, in a way that the whole world would understand, where would we store the first number in my array? 1, right? Does that make sense? Is anyone going to know 17? Because if we go 17, who else is going to guess that 17 is the first place you put your number for number 1? Right? So that's the whole thing. So if you look at your code again on slide 14, the not sure but many numbers, that's the name of my array, open bracket, and it goes counter. Counter is effectively keeping track of which position in the array we are at. So remember, counter is 1, then it becomes 2, then it becomes 3, 4, 5. So in other words, what it's doing is say, can you give me the number for number 1? Okay, put it in position 1. Can you give me the number for number 2? Put in position 2. Does this make sense? All right. Okay, now obviously this is a very abstract concept, but work through it. Practice doing this on your own and just watch how the code goes. And it will make a lot more sense this way. The reason why I did this whole fiasco thing is hopefully you all understand this is not examinable. You do realize this. You're not going to write, Prof. Learnden had a very, very messy box. That goes nowhere in any answer in any semester test. But what I'm trying to get at is making sure you all remember that these things are numbered and there's a position for each of them. Okay, can the last number be -1? I'm not sure what the last number be -1 would be -1. You can put -1 as a value to store in the variable, right? Because -1 is a number. Remember, this array is capable of storing integer values right across. Okay, Why is it not 0? Well, we don't, remember, we don't start with element 0, but I said we would discuss that soon. It will make sense to you eventually. All right, yes, there's a question. Sorry?
If we don't have counter in that line, we just say not sure, but now many numbers, and it says C input whatever. Would it store the elements randomly in the array? So it's for sorting out in the.
Okay, we're doing baby steps now. What we're doing right now is we're just storing the values in the in the various elements in the array for now. What we will eventually also want to do is we want to be able to access them. So right now this is just using the counters to say the value for number 1 must go in position 1. Obviously, that means that if we wrote this code further and we said, okay, we put the values in the array and we want to refer to them again later, you will be able to. And the way you do that is, again, using the name of the array and then open brackets and you specify the index. Okay. All right. So, is there no audio? Okay, I guess my iPad wasn't picking up. Okay, you can hear. Okay, great. Okay, so ladies and gentlemen, I'm going to stop here. Well, kind of stop here, but there's a few slides, and I just want to show you why. And we, you know, the whole question of, but why don't we start at 0? Because I want to start at 0. Because I mean, how many? Okay, quick question. How many of you count when you were told count to 10? Who starts at 0? Anybody? So who starts at 1? That's number 1. Well, it's number 2 reason why. There's a better reason which will become obvious to you once we do what we're going to do soon. Okay, but I just want you to prepare for next week. So on Eve, we've also uploaded a guide called the UJ Grid Guide. Now this is an additional new control we have to teach you, and it is only customized and created specifically for Informatics 1. And it's effectively meant to teach you how to work with what we call methods, okay, which are sub-programs. You're going to start creating your own sub-programs, which you're going to call, and they're going to do the same task over and over again. So we created a control called the UJ grid, which effectively answers this problem. Okay, there's this problem we've got. So if we now want to also display, so your question there of, okay, we stored the values, but what else do we want to do beyond that? We want to display it on our form so that the user can see, oh, these are the numbers I added up together, right? And you can imagine that this is going to be a problem. As you can see, that's not an error. It's deliberately cut off because can you realistically do that? Can you realistically create text boxes on your form to represent every number that the user is specifying? The answer is no, because you don't know how many numbers there are. So that here doesn't work. And the answer to doing this is actually, sorry, one more slide. No. Okay, no, I haven't spoiled it yet. So what is the answer? And I kind of spoiled it. We're using the UJ grid. So kind of, it's a table. So what we're doing is we want to fix this problem by being able to display, even though we don't know how many values there will be. All right? The answer is through a UJ grid. And to prepare for it, oh, I see what I did. So to prepare for it, please consult the UJ grid guide on Eve and try and install the UJ grid on your own machines. You don't have to install it on public computers here at UJ because they have been installed already. Okay, and the sneak peek, there's the sneak peek. So instead of multiple text boxes, you put down one control only. And from there, you use programming to specify how many rows, and that is what enables us to not know how many numbers there should be, but once the user tells us, we're good to go. All right, so yeah, the DLL guide, I told Mr. Levier to please upload the UJ grid to Eve as well, directly. It is actually in some other obscure directory on Eve, but we thought it would make it easier for you to access it directly. So thank you for reading it, Ciara Ross. What we will do is we will work with, we'll upload it. Okay, thank you very much. And then why don't we just use lists to work with arrays? Well, because arrays and lists are actually two different things. There are two different concepts to it. And so we don't actually work with lists, we work with arrays for a particular reason, which will be revealed to you in due time. All right, so thank you very much, ladies and gentlemen. Hopefully this was a very weird, wacky lecture today, but hopefully you enjoyed it. Please don't judge my messy box. Bye-bye.